In this video, we're going to look at inequalities, the symbols, and how to graph inequality. So for example, 1 is less than 2, and negative 20 is bigger than negative 30. And what we need to be careful is when we have two numbers, and on the number line, let's say we have 0 right here, and say 20 and 30. And on the number line, we know the numbers on the right-hand side are bigger than the numbers on the left-hand side. So 30 is bigger than 20. But if both of them are turned into negative numbers, so we know negative means the opposite of, so negative 20 is the opposite of 20. So it's going to be flipped to the other side. And negative 30 is the opposite of negative 30 is going to be the opposite of 30, so it's going to be flipped to the other side. As you can see, now negative 30, original positive 30 is on the right side of 20. That makes 30 bigger or 20 smaller. But once we flip them to the other side, because negative 30 is further away on the left, now that makes negative 30 smaller. Now, if you use real life examples, and which also makes sense, we know 20 degrees is less than 30 degrees, but negative 30 degrees is going to be less than negative 20 because it's 30 degrees below zero, which if it's talking about the weather, the temperature, that is definitely colder than $20. 20 degrees below zero. If we talk about money, which also makes sense, say if negative $30, negative $20, both mean debt now. From as positive numbers, they mean credit. So of course, $20 credit is less than $30 credit. But as debt, if we have $30 debt compared to $20 debt, of course we owe more money when we have $30 debt, and then which makes us less have less money than a person who only has $20 debt. Okay, so this is an important property. We need to be careful for negative numbers, so the relationship may not be this. We say we have 20 less than 30, but when we turn them into negatives, negative 20 becomes bigger than negative 30. So this will be used when we solve inequalities. And so when we listen to the weather report, it's the highest temperature is 43 degrees. That means the temperature today is less than or equal to 43. All the numbers, either the temperature today's highest will be 43, or any temperature less than 43. So this means it includes two parts. One is the temperature could possibly be 43, or the temperature is less than 43. So if the lowest temperature is 25, that means the temperature is going to be greater than. So if I use T to represent the temperature, so T is greater than or equal to 25, which means T is either 25 degrees. The temperature is probably will be 25 degrees, or the temperature is higher than 20 degrees. So now we're going to look at how to graph. So to graph inequalities, we first draw a number line. And we can think of this number line as a thermometer. So we're holding it in our hands and we're trying to read horizontally. So T here represents the temperature. So if T is at most 43 degrees, so we want to show on the thermometer. So if this is the 0 and this is 43. So first what we're going to do is we're going to find where 43 is on the thermometer. So on the number line here. So we found 43. And then because T is less than or equal to, which means we have to include all the numbers to the left of 43 because T is less than 43, smaller. And what if we have T less than 43 without this equal sign? So in order to distinguish between these two cases, so they are very close. The only difference is this one has an equal sign. So this means T less than 43 or t is equal to 43. But if you don't have a line here, that just means t is less than 43. So to show the difference between these two, because if I just highlight the number line, as you can see, it's looks exactly the same. So we cannot tell the difference by looking at the graph, which one has an equal sign, which one doesn't. So what we're going to do is, in order to show the difference, we are going to, if there's an equal sign, we're going to make this dot closed, close the circle. And the other way is, instead of using closed circle, we could use a square bracket, which means you're going to use something like this. So either way it works. But in order to show that t, in this case, t is not equal to 43 because we don't have an equal sign, then we're going to use an open circle. So open circle to say t is not equal to 43. Open circle. Here's closed circle. Or we can use a round parentheses. Actually, parentheses, because we only have half of it. So we could use a round parentheses. So either way, that will work. So you can see the difference. Now, if you don't have a highlighter, what you could do is you can raise at 43 and draw a line to go left. So that indicates all the numbers to the left of 43. So same thing here, we could draw a line and raise it. But make sure you either use close the dot here or use square bracket. So usually, I think most of us will use, instead of square bracket, we're going to use a closed circle here when we draw the graph. And this one, we're going to use open circle instead of the parentheses. So it's, okay, so next we're going to look at what if we have greater than. So 0 is here. Let's say first we're going to find the 25 on this thermometer. So let's say it's here. And same thing here, 25 is say here. Now, because the temperature this time is greater than 25 or equal to, so it has two parts, equal to. So again, greater than, that means all the numbers to the right. So I'm going to raise the line and draw the line and point to the right, all the numbers to the right of 25, and same thing here. But again, in order to show the difference between these two, so this, in this case, I don't have a little line. That means t is only greater than 25. T is not equal to 25. So we're going to use a open circle here and use a closed circle. Now let's look at example. So we want to state the solution set. So a solution set is a set notation. A set notation, all we need to do is to put this in. So whatever they give us, we put a curly brackets, and we write down the variable. In this case, the variable is x. So I'm going to write down the variable and draw a line to separate the variable and the condition for the inequality. So all you have to do is to copy this and just put it in here. And normally we always have x first. So we say either x equals 2 or x greater than 2, x less than 2. But this one is very tricky. X is on the right. But if we think about it, 2 is bigger than x. So if I use words, 2 is bigger than x. That means if I put x first, x is, compared to 2, is smaller. So if I switch x and 2, I have to flip the sign from greater than to less than. So you either can keep it as 2 greater than x, or if you want, or you can, if you like to put x first, you can say x is less than 2. So what we need to be careful is, when we draw the graph, we are trying to graph all the numbers for x. So of course, first we're going to find 2. So let's say this is where 2 is. And then we're going to graph x. But what is x? So again, 2 is bigger than x. So that means x has to be smaller than 2. So that means all the numbers to the left of 2. And also I use the open circle because there's not an equal sign here. So we need to be very careful we cannot just determine the direction to the left or to right by looking at the inequality sign. And previously, yes, if it's less than, to the left. If it's greater than, to the right, because they're bigger on the right, bigger numbers on the right, the smaller numbers on the left. But that's all of these cases. We always have the variable first, t first. What if the variable is on the right hand side? We have to be careful. So probably the best thing to do is to first switch x and the 2, and then we also have to flip the sign, because 2 is bigger, which means x is smaller. So and remember, the alligator's mouth eats the bigger. So again, 2 is bigger. So that means when we graph numbers smaller than 2. So that's going to be on to the left.